Hello there. My name is Merisek, and I am a master candidate at King's. I'm looking for a job in the data science field. I've been studying data science for the past year, and I would like a role that would allow me to put what I've learned to use, whether it's building data pipelines or creating and maintaining new models, or even maintaining databases. Hopefully, this job can offer me some flexibility, some exciting learning opportunities, and just general fulfillment. So, what's out there? Let's go over on LinkedIn and check it out.
We log in, go to the jobs panel, and look for a junior data scientist position in London, England. Let's check out this one. I see that it offers some of the key responsibilities that I'm looking for. So, building and automating data pipelines, building and optimizing, deploying models into live environments, and monitoring deployed models for drift and accuracy. But what about the flexibility, the excitement, and the fulfillment?
In this day and age, as job seekers, we're being constantly bombarded with emails, texts, and notifications about job opportunities in our areas. But how do we know which one of these is the right fit? If we're lucky, we find out during the informational interviews that we might not fit in with the company culture. In more unfortunate cases, though, it's after accepting the job offer and even starting the job that we make this realization. What if we could simply look at a job description and infer whether we would be fulfilled in this role? As an individual, I can personally recognize some potential red flags in job descriptions from my previous experiences and just from horror stories that I've heard from friends and family. For example, phrases such as daily reporting always make me question the type of flexibility that the role offers. However, I can only make these inferences based on my own personal knowledge base, which is quite limited, let's admit it. Now, how could I maximize all the knowledge available out there to make these inferences at a larger scale? This is the issue that I'm addressing in my MSc final project.
Using Anvil, I built a job listing interpreter tool where job seekers can paste the content of the job listing they're interested in and get insights on emotions that are generally linked with various sentences of the job listing. How does this all work? Let's start from the beginning. With recent advances in natural language processing, machines' understanding of human languages has developed significantly in the past few years. As a result, they're able to exploit the data available on the internet and turn it into useful information for decision making. Job sites like Glassdoor, for example, hold massive amounts of data related to companies. This includes job postings made by companies looking to fill new roles and reviews by employees that have worked or are currently working in these same companies. Incidentally, these are the two sides of the question we're trying to address in our project. By linking job postings made at a certain time by a company to reviews given for those same companies within the same time range, we train our machine to identify patterns, words, or groups of words in those job listings that give rise to the emotions present in the review. We break down this task in two parts. First, through Glassdoor scraping, we collected 90,000 reviews made about companies with tech related roles in the United States and the United Kingdom. From these reviews, we extract all emotions that can be identified. Emotion recognition is a subtask of text classification, which is one of the most researched tasks of natural language processing. Text classification, which is also known as text tagging, is the process of categorizing text into different classes or labels. Emotion recognition typically falls in the realm of multi label text classification. We're trying to identify zero or more labels, in this case emotions, from an input text. In recent years, deep learning algorithms have achieved state of the art results in text classification, outperforming previous machine learning techniques that were used. Specifically, one architecture that has outperformed other neural networks and shown exceptional results in text classification is the bidirectional encoder representations from transformers, or BERT for short. BERT was developed by Google back in 2018 after they realized the advantages that pre training models had in the computer vision field. BERT was pre trained on Wikipedia and the book corpus dataset. It was pre trained for two specific NLP tasks: mass language model and next sentence prediction. However, it can easily be adapted for multi label text classification just by fine tuning its training data and adding additional layers to it. This is the technique that we'll use to recognize emotions from our collected reviews. Here's what our model architecture looked like. We built a multi-label classification model on top of a BERT-based case, which is a pre-trained BERT model available in the Hugging Face Model Hub. We added a classification layer to it, and a sigmoid activation function on top of this base architecture in order to give it its classification, properties, or capacities. We fine tune it with the Go Emotions dataset, which is a very large collection of over 58K Reddit comments annotated with regards to 27 emotions like joy, anticipation, confusion, disgust, etc. This dataset is then split into a training set, a validation set, and a test set using a 70-15-15 ratio. The training set is used to train the model. Our validation set allows us to find the best hyperparameters for the model, and our test set is used to evaluate our model's performance. Following a phase of hyperparameter tuning with our validation set, we find that the best hyperparameters to train our model are a batch size of 32 and 3 epoch. After training, our model achieves an overall prediction accuracy of 96% on our test set. This means that out of all of the instances in the test set, 96% were correctly classified with regards to the emotions they contained. Since we're working with multiple emotion labels, though, and our dataset was quite imbalanced, accuracy alone does not give us the full picture of our model's performance. So we'll also look at the area under the ROC curve, which is also known as ROC for each emotion label. The OROC metric tells us how well our model can distinguish between our different labels, in this case, emotions. Notice that our highest OROC value is of 96%, which is quite outstanding, and our lowest one is 74%, which is still pretty good. We're therefore pretty happy with our model, and we can use it to predict the emotions that are present in the 90K reviews that we collected on Glassdoor. Once we make these predictions, we sum up the occurrences of all emotions per company and per semester, and we pick the top 3 most occurring emotions per company per semester. The reason we chose the semester ranges is because we assume that companies generally hold semi-annual reviews and have a chance to change up their processes every 6 months. This results in a data set of 1,000 companies with the top emotions associated with them for every semester. We use this specific information, so the top 3 emotions per company per semester, as our proxy for company culture, and we link these emotions directly to the job postings on the other side that are made by that same company in the same time range. We'll then drop all columns related to the company and the time period and directly link postings to emotions. This is the data set that we'll use to train our main model. This leads us to the second part of our tool, building the model which can link n-grams in job listings to emotions. Notice that this is also a text tagging task, more precisely a multi-label text classification task. Given the performance of BERT with our first model, we decided to reuse it for tagging our job listings. However, since we're particularly interested in n-grams that may raise flags in our job listing, we add a special type of classification layer on top of our BERT-based architecture, a convolutional neural network, or CNN. CNNs are well known for their great performance in text classification tasks. Through their n-size filter, they're able to identify patterns of size n in the input text and associate them with various labels. Even better, we can use a multi-channel CNN with a varying filter size, allowing it to identify differently sized patterns in the input text. This is a desirable property of our listing interpreter tool. Our resulting BERT model, hybridized with the CNN classification layer, achieves an overall F1 score of 79%. Here we look at the F1 score because we're more interested in minimizing the job postings that are mislabeled, and the F1 score gives us a better picture of this mislabeling. This final model is used as the backend of our job listing interpreter tool, and if we go back to it, I can paste a job description of a role I'm interested in, query the underlying model, and get insights on sentences in the job description that may raise some flags.
Note that this tool is a first jab at improving the job search experience for job seekers. However, we do recognize that it raises several questions resulting from the simplification of quite a complex subject, whether it is in the use of company reviews as a proxy for company culture, or just a lack of self-correcting feedback loop in our model. This naturally comes with some ethical implications with regards to the use of this tool and the way it should hold in guiding decisions. Future works could focus on these limitations. Thank you for taking the time to listen. I really hope you enjoyed this presentation.